Okay, so chapter 5 talked a lot about modeling real-world systems. What's going on here is we're really trying to solidify how you should think about objects and how you should work with them, because you want to make sure everyone's using the object the same way and not doing some wackiness. But really, you want to have objects that model real-world systems of some sort, so you can provide access to those systems. This is opposed to what you've been doing with procedural programming. Top-down or bottom-up approach. Approach is encapsulation into objects and interact with each other. So this is where we're going to a big jump. Beforehand, you're thinking top-down. You have these functions, implement the function, functional decomposition, or divide and conquer might be what it's called. What did y'all call it in Intro to C++? Divide and conquer, functional decomposition. What I'm talking about makes no sense whatsoever.
We did plug and chug.
You did what?
Plug and chug.
Plug and chug. Interesting. Okay.
So yes,
Divide and conquer. Y'all did. It's called divide and conquer. You have your problem. You divide it up into pieces, and then you conquer each part. I mean, that's what y'all did. I'm assuming. Okay. It's called divide and conquer. Top down. Functional decomposition. It's all the same word. What's happening now is it's better to think of the problem as you have objects communicating to one another. So it's a little different perspective on what's going on. The most important issue is to keep the public interface to a minimum. That way the interface is simple. Your programmers who use your interface know exactly what they're allowed to do, and then they move on. Let's jump over to at least a code example here. Let's see what we got. What are we doing? We're doing a student. So student has a student, and you can get its name and its ID, and you can actually get the student count. I think that was it. And we don't care about anything else. So that's an example of a simple interface. Hard to see back there? A little bit. Now for night mode. Whoa! All right. Okay. It's very helpful for debugging. You really want to hide the implementation. This was really helpful in this previous method. How did we hide the implementation? Ooh, in this example where we had student, classroom, and building. I think it'll make a lot more sense if we look at building. So what's the public interface of building? Actually, let's go look up what it is. So we have a bunch of code here. If you want to look up the public interface of something, so we created a building object, Paul of the West. You want to look at the public interface, dot, and let's see what we have. We can set the classroom. We can get the classroom by the classroom specifically, or by search by a student. So that's what its public interface is. Setting the classroom, getting in classroom by two other ways. What implementation is hidden here?
Get building.
The what?
Get building.
Get building. No, we already have the building. Do you care how Get Classroom works? No. So that implementation is, you don't even care what it's doing. You do it by classroom name or student. Do you care that we have a building which is composed of classrooms which each are composed of students? No, you just care that you can get a classroom when you ask for it. So that implementation of how that was done in the background is hidden from you. And that basically helps the user only have to think about, all right, you want to get the classroom? I just need the name of the classroom or the student, and I'll be able to take it from there. All right. Oh, I went into a lot of constructors. What to talk about in the constructors? Oh.
I hear what you said.
Oh. So it went into probably robust constructors. Why is the constructor so important here? It was a little too high level. Let's see if I can think of a better way of putting this. Let's see. Issues such as attribute initiation, memory management. Okay. Let's go with a classic example. So, I can tell we're a little tired here, which is fine. We did a student classroom building example, and that code probably is now gone from everyone's memory. I'm assuming that's what happened, which is fine. So let's come up with another example. What real-world object would you like to model?
A house.
A house. Okay. New. Java class. House. All right. So if you have a house, we'll say some data members. I don't care what right now. What do you want to be able to do to a house?
Build it.
Build it. So that would be the constructor, right? All right. Well, wow. We'll just use the factory method instead of using constructor. So we'll make it so you cannot call it the constructor. Boom.
What?
There. You can no longer call it the constructor because we made it private. So you want to be able to build a house, right? Okay. So we'll do public static house build house. Now, if you're going to build a house, you probably want to send it some attributes, right?
Yeah.
What do you want to be able to send it?
The floor.
The flooring?
Yeah.
Yeah.
Who knows you want hardwood floor?
String.
Mahogany.
Floor. All right, flooring. What else would you want?
Stories. Stories value.
Stories? You want how many stories it is? Okay. Rooms.
I like I didn't care about rooms first. I just cared about the floor.
Whatever, man. You know, it's cool.
Pools, you know?
Pools?
You want a couple pools
How many
outside?
pools you want? All right. Okay. Anything else? Door.
Oh, yeah. Yeah. Okay, you gotta have mahogany doors.
We have multiple pools and one door.
One door.
I'll go int num doors. Well, I'll put num in front of here so it makes more sense. Num pools, number of pools. Num rooms, there we go. Num
You
stories.
don't have numb stories. You just kind of like, oh, you're writing a bunch of stories and putting them in the house.
Yeah, that's what I thought too. Maybe they're just, you know, we're going to come up with all sorts of different things. Just shove them right in there for those
Bookcases that we have.
Yeah, for the bookcases.
bookcases. Oh, wow, that was good. Whew, I like that. All right, let's,
Someone's been paying attention in class.
all right, hold on. This is starting to get a little absurd, which is good.
A lot of components for a house. Can't forget about the wiring, plumbing.
Yeah. Oh yeah, you got bathrooms, man. Oh, are we just gonna put that in rooms? Gonna put that in rooms.
Number of wires.
Appliances. Appliances.
So how y'all doing?
I'm gonna count TV as an appliance.
TV as an appliance. All right. So you want to be able to build a house from a certain set of specifications, right?
This is a very odd house. This is all we got.
Well,
Yeah, no windows.
we have no windows. Man.
No, this is a programmer's dream house. We don't have a room either. Walls are for losers. We don't need no walls.
Num windows. Int. What was it? Oh, we'll just put roof.
Yeah.
Hopefully you just have one, right? Hopefully we have a roof. So roof type. All right. Anything else?
Garage.
The garage.
Is that
Oh.
a room though? Can you put that as a room?
Well, maybe you want the garage type.
Oh, okay.
Two stall.
I know I do, personally.
8 stall.
Yeah,
Two story. 8 stall.
Oh, that'd be nice.
2-story, 8-stall garage.
Yeah, you just drive your car and then lift it up.
4 stalls on each.
Oh wow, nice.
Yeah.
Now, would you drive in and lift it up,
Yeah.
or
Yeah.
you have a separate?
Next one
Oh, lift it.
I'm a car guy. I thought about it.
How high of a roof do you need, or a ceiling, to have that lift?
Pretty tall.
You're talking- I think my garage is 14 feet, so it's huge. It's really tall, I mean. But anyways,
Yeah, maybe you got like a bunch of low profile cars.
Yeah, you got my car. It's only like 5.5 feet off the ground. Or like at the tallest.
Okay. All right. Anything else you want to add to this set of ridiculousness?
We'll call that good for now.
All right, so you can construct a house. Okay.
Do we want walls or do we not want walls?
Oh my goodness.
We don't need them, honestly.
Wall type.
Oh, we
'Cause-
have windows. We don't need walls. They don't just be all window.
Well, then the wall type is called glass,
All
right? So you can have drywall, glass, veneer. Good old veneer.
Corduroy.
Corduroy veneer, yeah. Maybe you'll put wallpaper on your walls?
Maybe.
Maybe, okay. Okay. So, yeah.
This is a house right here.
Whew. So, So you build your house. We'll just return null for now. Notice I'm creating a stub because I have created the function heading. I have it just return something and I'm done. That's just a stub.
I have a question.
Yes.
So why would flooring be a string but everything else are?
That is a great question because I have no idea what we're actually trying to do here yet. So I'm trying to derive that from you, and I just started with string and
So we
realized
should-
we're going to stick with int for now.
So we should change wall type to a string too, garage type.
Okay.
And roof type.
So instead of flooring, would it be floor type?
Yep.
Okay.
Consistency.
Roof
Uh,
type. Now consistency.
All right. So I've stubbed that out. What else do you want to be able to do to a house? So now you have the house built.
Add on to it.
Add. Oh wow. Okay. Public void. What was it called? Additions.
Yeah, this is one.
All right. And what would you send to this addition?
Furniture. Send it furniture. New walls. Send it new walls.
This is going to get really terrible fast. All right. So we'll do string. What'd you call it? Furniture.
Yeah.
Okay. I probably should return a boolean because maybe the furniture didn't fit. Did you
Yeah.
ever?
Yeah.
Yeah. What else would you want to be able to add?
Destroy it?
Oh man.
Make it, get money from insurance, so.
Yeah. You burn it down. You just Molotov and hit it hard.
I'll do a string method.
Seriously? You're burning seriously?
Method. Well, how do you want to destroy it? I mean, right, you could light it up, wrecking ball. I mean, we got all sorts of things. Tornado,
You could dig a hole.
hurricane,
and
dig a
then
hole
through
underneath
it.
it. Yeah, have a crab. Yeah, I mean, we got all sorts of things
Yeah,
we can do.
Sinkhole right underneath.
I can't wait to see where we're going with this.
It's gonna work.
So we'll have this return true because it can always be destroyed by default, and we'll have the addition return false, saying you can't put anything in here.
Oh, it's like the-
Notice how I'm choosing the default action. Destroy, sure, we can destroy it. And additions, we'll just assume we can't add anything. Just trying to give it a decent default value. What else do we want to be able to do?
Insure it.
Insure it,
Yeah, If you're
okay.
gonna destroy it, you gotta insure it.
You gotta insure first, then destroy.
Yeah.
Sure, well, maybe, all right. Bull,
If you're smart.
what would it be,
Would it be a Boolean because you're asking like what type of insurance it has?
well, there would probably be set insurance, right?
Okay.
There we go, set insurance. I don't know why I put that in quotes. String type. Whew.
And you need to get insurance.
Oh, we have to get the insurance? Public string.
This is as bad as buying a house for real.
Yeah, y'all, I mean, y'all really picked a complicated one, by the way. It has no insurance. We don't believe in insurance. Okay.
We leave in the hand of God.
Yeah.
If it's destroyed, it's destroyed.
That would be one of the methods. Hand of God. I like that one. Hand of God. All right. Anything else we want to do to this house? Because this is going to get ridiculous fast. Well, I mean, if we have a house has roofs.
It has
How do you pronounce that word? I've been around too many Canadians.
Yeah, that's why it's not there. It's no
Sorry,
word.
Canadians. I didn't mean that as an insult. All right. So, well, yeah, you want to be able to know what the roof is. You want to know what the pool is, what the appliances, the garage. Are the cars in the garage?
Yes. Yes.
Well, hold on a second. Now, our object's going to start getting pretty big if we add this in, right? We're going to start getting some crazy.
We can use the get and send insurance on the cars too.
Okay. I wish we had interfaces
cars.
because we could set something to be insurable. That would be the house and the car, but we'll get to that later. Okay. If I were to, because let's just stick with floor right now. You have different floor types. Okay, that actually might not be too bad. You have different floor types, but you may have different floor types per room, right?
It's not doing
But we're modeling a real world thing, so we gotta be realistic, Tyler. You chose house, not me, okay? All right. This is you. This is all you. So if we had rooms that each could have their own floor type, how would we going to store that?
Oh, I just put it in an array.
Put it in an array.
Yeah. You got so many floor types.
Yeah, but how will we know which floor types to which room? How are we storing which room we have? Are we storing how we have rooms? We just have a number of rooms. What do you think we need? The type of room? Right, okay, so we need to figure out the type of room in each of the rooms. Oh boy.
Oh Lord. Okay, this is like a 2-room house.
Shut it down quite a
Yeah,
bit.
it's a 2-room house. That's it.
No, we got to model real world here. If we want to have multiple rooms, each room may have different floors. And each room might also have windows or no windows. Might have appliances in it. Right? Then you also may want to know what rooms that room can connect to. What does it sound like we should be doing?
Separate objects.
Scrapping this whole idea.
It's too late, Tyler. You already committed. What does it sound like we should do with room?
Like a room out there.
Divide it out, okay. If you divide, what would you say?
The same. They make a room object.
Make a room object. So now we can have a room object communicate with the house object so they can communicate to one another. Beautiful. All right. So let's create a room object. It's going to get so ridiculous. All right. So it might have some private data. Okay. We'll go ahead and have a default constructor here. What do we want to know about the floor? The room.
Floor.
Thank you.
Number of windows.
Floor type, int num windows,
Number of doors.
num doors,
The wall type.
so string wall type. Anything else? Nothing right now? All right. Wow, this is getting crazy. Okay. So if it's storing the floor type, number of windows, the number of doors, and the wall type, we probably should have those as private variables, right? Good. Everyone nod your head. Thank you. Wall type, private, int. I misspelled private. Wow. Num windows, thank you, IntelliJ, for hiding it from me. All right. Num doors. All right, we'll just store it. So floor type equals floor type, and then what do we got? Wall type equals wall type. Oh man. Num windows equals num windows. And then m num doors equals num doors. All right.
Num windows equals 95.
Whew, that was good. All right. Let's see if IntelliJ can help me out here. I can do create getters and setters for M floor type. Oh, that was beautiful. Let's do that for each one. I put my cursor over it, did Alt Enter, and said create getter and setter for everything. Oh, that's beautiful. Oh, I don't have to type code. Now, the other thing that's annoying about this is I put that little M in front of it, so I'm just going to delete that. Alright, so it's very common to create a simple object that just gets and stores a bunch of things but groups it together. So this is kind of monotonous, but it's very important. Ooh! What is this? Haha.
It's that specific one, in that spot.
What's the this pointer?
Unnecessary.
It's unnecessary here. Why is it unnecessary?
Because you're only working with, well, with one room.
What does this point to? Hmm? The current. It's the current executing object. So notice I go this dot, and now I have all the private member variables I have access to right up here, as well as the public functions. This always refers to the executing object.
So at this point, the executing object would be the room.
Right, the room. So it's superfluous here because that it's also functional equivalent to this line of code. I'll just put it under.
So why use it?
So why do we use it? Well, right. Actually, I take that back. Oh, this is great. So I'm passing M floor type, right? And I say this dot M floor type equals M floor type. Problem is, if I get rid of this dot, what is M floor type referring to? It's referring to this over here. But if I put this in front of it, then this dot M floor type, this guy is referring to this one, and regular M floor type is referring to him. Okay? So that's why this is important.
How'd you do that? You put your cursor over it and right-clicked?
To generate the getters and setters?
Yes.
So I put my cursor over the variable I want to generate a getter and setter for. And then I did Alt Enter. And then there was an object for an option to create getters and setters. And I just said do it. Or I hit Enter on top of it. Wow. Okay. So if we're back over here, where's building? House. Welcome. Ooh, wow. Wow.
Very welcome.
Huh?
I feel very welcome.
You feel very well? I'm glad.
Were you expecting story time this time?
50 minutes. You better have a good one. Actually, I think that's 40. Never mind. But that's still.
It's closer to 30. See, what happened was about the genie's lamp, right? And instead of 3 wishes, I only got 2. My third wish was going to be on class on time.
Uh-huh. Oh, okay.
But you wanted a new Lamborghini first.
Well, now you owe me the Lamborghini.
But good thing you wished
No,
for 2.
no. See, he said it was going to take a couple months to get to me.
That's fine. I can wait.
Okay.
As long as it happens before I post a grade, we're good.
Okay.
Okay. So now that we have a room object, how should we change our house building function? Are we going to have int num rooms? What should we have instead? Tyler?
room.
Okay. All right, that's a good start. So we'll go room, room. Why does it not like this word? Oh, why do you have to import that? Wait, where's house? Oh, house is here? Who did that? No, don't do that. Put it up here. Yeah, refactor. That's just silliness. All right, much better. Whew, that was bad. Room, room. Okay. So how many rooms is this house going to have?
5.
No,
Seven.
just 2 rooms. We need to keep it simple, because we've already.
I said
dug
five.
ourselves.
I know. I think we need to go all out here.
No.
We're going all out.
Too far gone.
Are we counting the kitchen and the living room as
Yeah, you got kitchen, garage. How's garage?
so 5?
So, well, how many can you pass to this function?
Bathrooms count?
Sure.
That's what I'm saying. Like 2 bedrooms, a kitchen, a living room, and a bathroom.
Well, you want to be able to build a house, but you want to be able to specify how many rooms there are. But right now, how many rooms can you possibly pass to this function?
So we need one. Oh,
Just one.
just one. Oh yeah.
Hmm. Hmm. Anyone? So how can we fix that?
What are we fixing?
Currently, we can only build the house with 1 room. How can we fix it so we could build, more than 1 room?
Just actual. If you could say room 2, room 3.
Yeah, but we might have a house with 2 rooms, a house with 5 rooms, a house with 25 rooms.
Array? You want an array?
An array. Okay, we'll do an array. Let's see if Java. Oh, Java wants it on the variable. Okay. Great. That was awesome. Good. So if you have a room, you have your house, has a room, be able to get an addition with furniture, and destroy the house. So let's just focus on the room, because this is going to get crazy real fast if I try and do everything else. So we'll do, have I talked about lists in here? No lists? We'll start talking about lists. Array list of rooms. Ooh, that's some weird syntax. M rooms. What am I doing here? I'm making a list of rooms. That's all. So we'll do, inside here we'll have house, ret equals new house, ret.m rooms equals new array list. Okay, granular.
Why that?
Because that's our variable. Ret.m rooms.add. We'll do a room sub 0. Well, actually, we want to add all of them, so we'll do for int I equals 0. I is less than room, so that should have an S in it. Let me go fix that. There we go. And we'll have m rooms.add rooms. Cannot be referenced from static contents. That's because I want ret.mrooms. Rooms sub I. Ooh, so what is this code doing? Well, start a house object. Initialize the room list to empty. Add all rooms passed in to the room list. Okay. And we'll have it return the house. Return the constructed house. Okay. So we have a bunch of rooms, and the rooms have a bunch of different types. What is? What else would we want to be able to do?
Locate the rooms. Okay. So we want to be able to get these rooms. Public find room. What are we going to find it by?
Number.
Number? Wow, we never gave the room a name? Wow, we are terrible people. Private. Well, let's put it up there. Probably should give it a name, right? I'm just going to throw that out there. We'll start with the name. And we'll go ahead and do some getters and setters here. Okay. So you probably want to do it by string room name. You probably want to return the room. Okay. So we want to do, how do we do this inside of with an array list? I talked about it with an array, but how do you do it with an array? Well, for int I equals 0, I is less than mrooms dot size. This is similar to the array list, I++. And then you just test if the mrooms dot get sub I, so that's room sub, like the subscript I, dot get name equals the room name, return mrooms dot get sub I. Wow, I just typed that real fast without telling you what's going on. So let's see who can explain the code to me. Something finished. So what's the for loop do?
Runs through the array.
Through the list, through the array list. Okay.
So you get into position, and then its name.
Now what do we do down here? So run through the list. Now what do we do?
Finding the room.
Find the room by the name. Now let's read this from the beginning. mrooms, that's a list. Get I, get the ith element, the ith room. Get that room's name. Is it equal to the room name passed in? If the answer is yes, return it. Otherwise, keep going. So if I'm down here and I've gone through it and I haven't returned a room, what does that mean? It doesn't exist. So we'll return null. Okay. Wow. All right. Do you see how the house object has rooms in it? So the house object has rooms. No,
So would that be better than doing an array? Or
With
are they
the array
both
list?
about the same?
they're going to be about the same. I need to start getting used to doing it this way. And it'll make a lot more sense when we start talking about lists, how to use lists, why we're using lists, etc. But let me start. This is really how you're supposed to do it in Java. Usually you don't use arrays, you use an array list. But you can make an array. Okay. Yeah, so pass in the rooms, put it in a list, and then later you can get it. And then later it's asking. So house has rooms, and you can return a room, because if you try and find something in it, it's basically going through and querying each room asking, are you this name? So do you see how the house object is communicating with the room object through an array list object? All right. Start thinking about how objects are communicating to one another and less on top down. All right, error handling.
Is it gracefully?
See, what would be a good error here? Oh, right here. The room didn't exist, we return null. We didn't terminate the program. We just said it doesn't exist. You could also up here as if, and you should do this in your lab, room name equals null, return null. You don't have a room name? It doesn't exist. Documenting class. Make sure you write comments Wow, cooperating objects.
Whoa.
So this is cooperating objects. Which objects are cooperating here?
House in the room.
The house and the room. They're cooperating to each other. They're sending messages to one another. The message is being sent, well, right now it's just adding it and being able to query its name. Designing with reuse in mind. Ooh, that's a good question. Have we done anything here to design with reuse in mind with our house object? What have we made reusable?
Finding a room.
Finding a room, all right. So we've divided out how a room functions from the house. So anyone else can now use the room object later. Maybe if they want to use it for, what would be good? Build some other an office building and not a house. Maybe a playhouse. The garage has multiple rooms. You can reuse the room object for other things. Now is what we're trying to get at. Extensibility. Wow, this one's hard. This one's hard to see. Don't rewrite everything, but consider the future use of a class when designing it. That's why we divided out rooms, because in the future, well, actually, hold on, let's think about this differently. House, build. Oh yeah, so we made it so you can have a list of rooms. So now if someone wants to have a house with 100 rooms, that's still okay. So we've added some extensibility or future-proof here. Not future-proof, but extensibility, in case someone wants to have a ton of rooms.
In case Oprah wants to build a house.
Right. Descriptive names. Hopefully you'll have, you've had practice with C++. Obviously, floor type, it's going to be the floor type. You shouldn't call it something crazy like Superman. That doesn't help. Actually give it a descriptive name. I actually had one programmer, instead of for int I equals 0, I is less than size, he really would write superhero names. So it'd be int Superman equals 0 up to size, or Batman, or Green Lantern, or whatever. Yeah, we had to let that guy go. It was bad. Make sure your names actually make sense. Isolating non-portable code. This is actually not too important. We're not going to talk about native code in this class, but keep in mind that Java was developed to be as portable as possible. But if you run into something that's not portable, a device driver, something with kernel using OpenGL, although OpenGL is somewhat portable, you want to isolate that into a separate class. But we're not going to really delve into portability here. Copying and comparing objects. Oh. So you need to be able to copy and compare objects. Do we talk about it? No. Great. So a room. How do we compare a room? How would we compare two rooms? By the name? In Java, what would we actually do? Ooh, did we talk about this? What function have we been using with string to compare two strings? So if you're going to compare two strings for equality, how do you do it?
You have to give it properties first.
If you do two equal signs, what is that actually comparing? The memory location. So what do we have to do instead?
Dot equals.
Dot equals. Yep. So if you want to, it's very good to write a comparison function. So public boolean equals, passing in a room. And let's see, boolean equals. So you probably just want to return this dot mname dot equals room dot get name. So just return if those two are actually equal to one another. That way dot equals is actually doing something meaningful. Actually, what's cool about that So we jump over to our house object. How can that simplify our find room? Well, no, it doesn't simplify it because we're not being passed a room. So never mind. But if we were being passed a room, we could have just gotten rid of get name and just do dot equals. But we're passing in a string, which is okay. Minimizing scope. Here's a good example. Does the house object have to store floor type, wall type, name of the room, number of windows, number of doors now? No. So the scope is now being drilled down into the room itself. It's not part of the house. So think about how far can you drill down the variable. Obviously, the house is going to have to keep a list of rooms. There's no way around that. You can't store the list of rooms in a room. That doesn't make any sense here. So obviously, it needs a list of rooms. But the walls and whatnot of the room can be stored in the room object and not in the house object. So that shortens or minimizes the scope. Class responsibility. What was this, Tyler? Did I say this a lot? Was it single responsibility principle?
Yeah.
So this is vital, although it's still high level right now. You want the room object to take care of only the rooms. You don't want to worry about the roof. Don't put roof type inside of room. It's not its responsibility. The room object is only responsible for a room. Don't start mixing the responsibilities. You'll start seeing this. This happens a lot. Right now, that seems obvious, but you'll run into a lot of situations where all of a sudden you have two different things happening at the same time. Maintainability, wow. Okay, that's hard to understand right now. Iteration. All right, so we have a house object. We've designed how to add rooms. What would we do next?
Add a room.
We could add rooms. Let's say we got the roof stuff done. What would we do next?
Probably want to figure out how many pools you're going to have.
Yeah, pools. All right, number of pools. All right, notice. Good. So we could work on pools next. It'd probably have some list type structure as well. Or maybe the roof. But notice first I drilled down, I got the rooms taken care of before I went on to the next thing, aka before I iterated to the next step. That's the idea. You have your high level view, we divided out with rooms, we took care of rooms. All right, we're saying rooms works for now, then we would go to the next step. So it's good to do it one step at a time, make sure each piece is working. And you want to go through more testing than this before proceeding to the next step. That way you're not have a convoluted mess. That's what it means by make sure you take an iterative approach right now. Testing the interface, called stubs. We're going to get into testing in a moment. Object persistence, maintain the state of an object when you run the program. If you don't, save the object in some manner, the object dies, never to be recovered. So, object persistence. If you have a database and you need to store the object in a database, you have to come up with a way to save the information there and then be able to reload the object later on. Or if you're currently running, you want to make sure the object stays in memory the whole runtime of the program and doesn't disappear. So you always want to have a handle to it. That's what it means by persistence. In most business systems, keep in mind that these objects, rooms and whatnot, would have a method to store itself to a database and then read itself out from a database and recreate itself. Just keep that in mind with persistence. Hopefully we'll get into that later. Marshalling will be a huge topic that we will get to. Marshalling is how you serialize the object, aka how do you take your object and store it in the database. How do you convert it to a database? How do you convert it back? But keep in mind that's called marshalling, and we'll get to that later in this course. Great. Okay. Any questions on that? There's probably a lot of high level stuff, but hopefully that helps give you another example of how you should think about creating objects make sure you think about how they would interact with one another, because we're talking about how the house object is going to interact with the room object. Any other questions? Before I go to the next step? All right. How are we doing on time? Okay, all right.